If a ball is thrown vertically upward with a velocity of 80 feet per second, then its height after t seconds is s, which is equal to 80t minus 16t squared. What is the maximum height reached by the ball? So we first are going to look at what the position function tells us. And the position function is s, which is equal to 80t minus 16t squared. Okay, and so what we want to do is we want to be able to find the velocity function. So the velocity is taking the derivative of the position function. So we get 80 minus 32t. And so what we want to do is we want to figure out what is the time when the velocity is equal to 0, meaning what is t. Okay, so if we take a look at that, we know that if we take the velocity function, which is 80 minus 32t, and set that equal to 0, if we subtract 80 to both sides, we get negative 32, which is equal to negative 80, and divide both sides by negative 32, and we get t, which is equal to positive 2.5. So the time, okay, that it takes so far is at 2.5. That is the maximum time that it's going to take to reach the ball. But now we want to plug that time in back into the position function to determine how or what is the maximum height reached by the ball. So knowing that t is equal to 2.5, and then we're going to plug it into the position function of 80t minus 16t squared. So s is going to equal 80 times 2.5 minus 16 times 2.5 squared. So therefore, we can say that the distance is going to equal 100 feet. Okay, so next question says, what is the velocity of the ball when it is 96 feet above the ground on its way up and on its way down? So imagine that we throw this ball and then it goes up and it hits a maximum and then it goes all the way back down. Okay, so we just determined from part A that the maximum is at 100. So that's 100 feet. Okay, and what we want to determine, okay, is when it's at 96 feet, according to this question. So we want to know what is the velocity when it's going up, and then what is the velocity when it's going down. Okay, so what we're going to do is we're going to take the position function. Okay, so we know that the position is s, which is equal to 96, and we know that the position function is equal to 80t minus 16t squared. So we have 96, which is equal to 80t minus 16t squared. And now we're going to set this equal to 0. So we're going to bring everything to the left side of the equation. So we have positive 16t squared minus 80t plus 96. And we're going to set that equal to 0. And then we can factor out the 16. So we have 16 times t squared minus 5t plus 6, which is equal to 0. And if we divide both sides by 16, then what we have left is t squared minus 5t plus 6, which is equal to 0. And now we're going to factor. When we factor, we get t minus 2 times t minus 3, which is equal to 0. So what does that tell us? That tells us t is equal to positive 2 and 3. So that's 2 and 3 seconds. So now we're going to use the velocity function. Okay, so recall that the velocity function that we got from the beginning was 80 minus 32t. So let's find out what happens when t is equal to 2. So when we find v of 2, well, that's going to equal 80 minus 32 times 2. And that's going to give us 16 feet per second. And we want to find v of 3. So that's going to be 80 minus 32 times 3. And that's going to give us negative 16 feet per second. So that means the velocity going up is 16 feet per second. And then the velocity that's going down is negative 16 feet per second.